Alright, so we're going to be looking at exploring limits numerically now. So what that means is that we're going to be using a table. So let's look at this example, which we looked at above, which we want to explore the limit of x cubed minus 2x squared all divided by x minus 2, and we want to look at x values specifically approaching from the left. So we want to use x values that are less than 2. So if I want to look at x values less than 2, I would do values like 1.9, 1.99, 1.999, and 1.9999. Right, we want values really close to it but not actually approaching it. So you can totally plug this into your calculator and do that, that's fine. I'm going to show you guys the faster way. Remember, if we go to Desmos, we're going to type in our function. So f of x equals x to the third minus 2x to the second divided by x minus 2. Okay. Now the next thing you're going to do is you're going to hit the plus button. You're going to go down to table. You're going to change this to x, and you're going to change this guy to f of x. Now we're going to plug in our values. 1.9, 1.99, 1.999, 1.99999. Okay. Now, if we take these values and we write them into our table, 9. There we go. Okay, so we're going to have that we get out 3.61, 3.96, 3.996, and I think the next one was 3.9996. Well, what I can see is that as my x value gets closer to 2, what are these values getting closer to? These are getting closer to, well, it looks like it's getting closer to 4. So, numerically, we would say that that limit equals 4. Now, the reason that you'd like to do limits numerically instead of on a graph is sometimes graphically you can't zoom in close enough to see the specifics of what's happening, or the graph is just going so crazy that you can't really say exactly what it's approaching. Alright, let's look at the next one. So we want to look at the limit as sine of x divided by x approaches 0. So again, what we are going to do is we are going to type that function in. So we're going to type in sine of x divided by x. And we want to do different values. We want to do values that are bigger than 0 and values that are smaller than 0. So values bigger than 0, I would do like 0.1, 0.01, 0.001, 0.0001, and then for values less than 0, I would do like negative 0.1, negative 0.01, and so on. Alright, so let's go ahead and type in those values and see what it looks like our function's approaching. So if we do 0.1, 0.01, 0.001, 0.0001, okay? Well, what has happened is it looks like we have 0.998, 0.99999, 0.99999, and right here, this is actually point bunch of 9s, but what our calculator on Desmos has actually done is it's got so tired of writing out all of these 0.9999s that it just rounded it up for us. So what we have is we have 0.99, 0.999, etc. So on this side, it looks like our values are going to be approaching 1. Now, let's also make sure that we approach from the other side, we're also going to get 1. So if I look at these values and I just plug in a negative in front of them, okay, it also looks like they are also approaching 1. So these values are also approaching 1. So overall, I would say that the limit of this is 1. Alright, now let's look at a piecewise function. So we're going to let f of x equal, now we have two choices depending on what our x value we're plugging in is. If our x value is less than or equal to 3, we're going to plug our x into x squared plus 2 in order to get our y value. If our x values are greater than 3, we're going to plug it into x minus 5 to get our y value. So for this first one, we have the limit as x approaches 3 from the right. That means we're going to be choosing values of x that are greater than 3, which means that we're going to be using this bottom one. So when we plug that in to get our y, we're going to be plugging it into x minus 5. So we're going to be plugging in values greater than 3, so let's do 3.1, 3.01, 3.001, and 3.0001. All right, so when we plug those in, here's what we're going to get. We're going to get negative 1.9, negative 1.99, negative 1.999, and negative 1.9999. So what it looks like our function is approaching as our x approaches 3 from the right-hand side, it looks like we're approaching negative 2. Now, the limit of f of x as we approach x from the left-hand side, sorry, there shouldn't be a 1 there. So as we approach it from the left-hand side, okay, that means that we're going to be choosing x values less than 3, so we're going to be using this guy. So to get our y values, we're going to be using x squared plus 2. And remember, we're choosing values less than 3, so we're going to have like 2.9, 2.99, 2.999, things like that. So if we take those values and we actually plug them in, here's what we're going to get. We are going to get 10.41, 10.94, 10.99. So what it looks like we're approaching is it looks like as our x gets closer to 3 from the left, so remember, values less than 3, looks like our y value is getting closer to 11. Now, the last question is, what is the overall limit of our function f of x as x approaches 3? So let's just draw a picture real quick. Okay, so we have our x value of 3 here. Now, as I approach from the right-hand side, okay, what it looks like is happening is it looks like I'm going to be plugging in my function into x minus 5, and it looks like the y value is going to be approaching negative 2. Okay, so that is going to look like this guy. Okay, so I have negative 2 for my y value. Now, as I approach from the left-hand side, I'm going to have x squared plus 2 as my graph, and it's approaching 11. So remember, x squared plus 2, that's going to look like a parabola. Okay, so it'll probably look something like this. Now, here's the issue, is as I approach from one side, I'm approaching 11. As I approach from the other side, I am approaching negative 2. So what does that mean about the overall limit? That means that the limit as x approaches 3 of my function, well, since it's broken and they don't share a common point, that is going to be d and e. Awesome. So the very last question I want you guys to do is, I want you to explore this one on your own. So go ahead and pause the video, and I want you to explore it 2 ways. First, graphically, and then I want you to explore it numerically. All right, so now that you've unpaused the video, let's do it graphically first. So let's go back to Desmos. Okay, and we're going to type in 3x divided by x minus 4. Now, if I look at this graphically, what I can see is as I get closer to x equals 4, so let's just type in x equals 4 right here. Okay, it looks like one side is shooting down to negative infinity, and the other side is shooting up to positive infinity. So just by looking at the graph, I'm like, well, one, both sides are going to infinity, and they're not even going to the same infinity. So I would say it does not exist. Now, doing it numerically, which means using a table, remember, we have to check both sides. So first, let's check sides that are less than 4. So let's do 3.9, 3.99, 3.999. Now, as I approach 4 from the left-hand side, so values less than 4, notice that my y values are negative, and they're getting more and more negative, so they're becoming larger negative numbers. So I'm right, it is shooting down to negative infinity as I approach from the left-hand side. Now, if I approach from the right-hand side, so choosing values a little bit bigger than 4, so like 4.1, 4.01, 4.001, these numbers are getting bigger in the positive direction. So as I get closer to 4 from this side, my y values are shooting straight up. So what I have both numerically and graphically is that my limit does not exist.